Now, today we'll be seeing the XS3 code. Now, we have already seen what is the necessity of coding. We have seen what is binary coded decimal number. Means each decimal number we code it with binary 4-bit binary number, okay, or each decimal is represented by 4-bit binary number. It is also called as 8421. What is the why the reason is that BCD code is also called as 8421 code? Because it depends that 8421 is obtained by assigning the positional weight of the binary number, isn't it? And what we know about this, so we can represent a number only from 0 to 9. So when it exceeds 0 to 9 or after 9, if the number is say 1 0, we split into 2. We do not consider the number. So number from 0 to 9 is valid and after 9 is invalid. Followed? Remember this. So same way XS3 is, but BCD is a weighted code because of the positional weight. So the next type of code is XS3 code. It is also extension of BCD code, or it is called as a modified BCD code. So this XS3 code is an unweighted code. Remember that it is an unweighted code. Then how do you obtain, suppose you have been given any decimal number or a 4-bit or n number of bit of a binary number, how will you convert the given number into a XS3 code? So the procedure is that we take, if you have been given the, or why it is called XS3 code, this is also the this part in it. Followed? So suppose you have been given a decimal number, you convert that decimal number into binary, or for easiness keep the decimal number first, do the conversion, find the XS3 code of it and then represent it by binary number, because it is a extended form of, or it is a modified BCD number. Remember that. Now then how to find, so to the given decimal number, as I told, it is a BCD number, so we'll split the numbers and each digit whichever you have in your decimal, suppose it is a single digit, no problem. If it is a 2, 3 digit, n digit decimal number, so each digit you are supposed to add 3 to it, okay, add 3 to it. Whatever number you get, that number is called, or value, the result which you obtain is called as a BCD number. Remember that. Followed? Now suppose, but why, that's why the reason is that it is called XS3 code. XS3 code means what? You add 3 to a single digit decimal number. Now the reason is that, or the thing is that in this, why it is called extended BCD number, this extended BCD number, because we know that BCD number, when we exceed 9, it is considered invalid. So suppose the case is that when we are adding BCD number to decimal digits whose sum exceeds 9, means I am talking about the two BCD numbers whose sum exceeds decimal 9, so what will happen? It will be considered as invalid. So to avoid this problem, what we do, we use the XS3 code there, okay. We use the XS3 and convert the number into a valid form. So this type of XS3 code is also called as self-complementary BCD code. Remember that. Self-complementary means, complementary we have seen, self-complementary means by itself it gets complemented. Remember that. This is what is a XS3 non-weighted code, but BCD is a weighted code. Remember this. Now suppose some example is shown in your slide. So one example, first it is shown as 23, you have to convert it to XS3 code. So for 23 means 2, 3 will consider, will separate the numbers 2 and 3, and starting from the rightmost digit to the left, here only 2 digits are there. If there are more number of digits, will always start decimal number, we start reading or we add or whatever we do, we start from the units place value, isn't it? So first we'll take the number 3, separate the digit 3, add 3 to 3. Suppose the next number is 2, add 2 to 3. Followed? So each digit whatever we have, we are going to add 3, and whatever result we obtain, it is the excess 3 code for the given decimal number, and represent separately in a group of 4-bit binary number, and combine and write the result. Followed? This is clear? So this is what is, how do you obtain excess 3 code. There is one more number shown, convert 12 to excess 3. So simple 12, again what you will do, separate the digit 2 and 1. First add 2 with 3, we will get 5, add 1 with 3, we will get 4. Write the BCD equivalent of 4 and 5 separately. Clear? Suppose now the result will be more than single digit. So what you will do in that case, suppose you get result as 12 or something. So split the digits and write its equivalent BCD. Followed? So remember what is an excess 3 code. What is the simple thing you will remember about excess 3 code? You have been asked to convert, if it is in binary number which has been asked to convert to excess 3, convert it into decimal, or if you are familiar with what is the equivalent binary of the given numbers and add binary 3 to it separately and obtain the equivalent result. So it is called as excess 3 code. So as soon as you relate the term excess 3, what should come in your mind? That you are adding 3 to a single digit decimal number to convert any given number into excess 3 code. So this is what is excess 3 code. One more important thing you will remember about excess 3 code, it is called as a self-complementary binary coded decimal number, or it is also called as, you will find this term being used as self-complementary. It is a self-complementary code. So it is little actually not that efficient as compared to binary number. It requires more space and more time to transmit the information, and it is also complex sometimes, but still it is used in some required places. Followed? So this is what is your excess 3 code.